Hello, my name is Dylan Faullin. I'm an instructor at Dodge City Community College, and I'd like to show you how to do this particular problem here. We're being asked to solve the equation and determine if the equation is an identity, inconsistent, or conditional. All right, so we're going to try to solve this equation, and of course the rest of the directions, having that extra bit in there, kind of tips off that we might expect something unusual to happen, and so that's what will probably be the case for this particular problem as well as the previous one that we just did. Okay, so whether or not it's going to be one of these special cases, identity or inconsistent, we have to try to solve this equation, right? We can't really know ahead of time until we try to solve for x. And so to solve for x, this is just like the previous problem. We need to get x by itself on one side of the equation, and we can't do that while x still exists in two different places. And in order to get x together in one place on one side of the equation, the parentheses needs to be out of the way, right? That x over here inside the parentheses is trapped in there. It cannot interact with any other x's outside the parentheses. So we need to get rid of the parentheses, and we can do that by getting rid of the reason the parentheses are there to begin with, which is this 3, which is being held outside the parentheses, I like to say, right? We need to distribute the 3. By distributing the 3, the parentheses are no longer mathematically necessary, and so we can drop them. Right. So what we're going to get here is 3x minus 18 on the left-hand side. And on the right-hand side, I'm just going to copy this down, 3x plus 18. All right, so continuing on, the next thing I like to do is get all of my x's to one side of the equation. So I'm going to eliminate x from one side so that it only exists on the other side of the equation. And typically what I like to do is eliminate x from the right-hand side. All right, so we have a positive 3x over here. I can eliminate it from the right-hand side by subtracting the 3x away from the right-hand side. And so the x's cancel out. But if I do that to the right-hand side, I have to do the same thing to the left-hand side, and the same exact thing happens on the left-hand side again. The x's are going to get canceled out over there as well. So not only am I getting rid of x from the right-hand side, it completely disappears from my equation entirely, right? So unintended, right? Didn't mean for that to happen. I'm trying to only get rid of it from the right-hand side, but it removes itself from the left-hand side as well. And when this happens, we can feel a little directionless, right? Because x is really our primary objective. It's our goal. It's what we're aiming for, getting x by itself. And when x completely disappears, that's a little bit unsettling, right? On the left-hand side, what happens when the x's cancel out? We have this negative 18 left over, right? There's an 18 here left over, but we can't ignore the minus sign that we have here, which becomes a negative sign when the x disappears. So we end up with negative 18 on the left-hand side, and on the right-hand side, we have positive 18. All right, so we get this statement, negative 18 equals positive 18. There's no longer an x to solve for, and so we just have to judge the situation based on what we get here, and what we have here is completely ridiculous, right? Negative 18 is not the same thing as positive 18. They are not equal to one another, and so what I like to conclude about this is that this is never true. Right? Negative 18 never is the same thing as positive 18, right? And if the conclusion is never true, the original equation was never true either. Meaning that no matter what I try to plug in for x to this original equation, it will never ever be true. And if it can never be true, that means there can never be a solution to this equation. Right? So what happens here is if you try to solve your equation for x and your variable completely disappears from your equation, then it's going to either be identity or inconsistent. And if the result that you get when the variable disappears from your equation is never true, then you have an inconsistent equation. Because the equation is never true either, which just means it's complete nonsense. Right? The equation is completely nonsense. And in a case where you can never have a solution, that means there's no solution to the equation. Right? It doesn't matter what you plug in for x. This equation has no solution. And a nice symbol for that is this sort of 0 with a line through it, right? Which represents what's called the empty set. So we're saying the solution set is empty. There's nothing in there because there's no solution. Right? So this is our final answer. Right? Make sure you put both, that it's inconsistent, that's the type of equation it is, and also that there's no solution because the directions are asking us about what the solutions are, and we want to make sure we're clear. There are no solutions to this equation. All right, thank you.